Let's look at series with a show that question on squares and cubes. So the example says, show that the sum from r equals 1 to n minus 2 of r brackets r plus 1 all squared equals to 1 over 12 n brackets n minus 1 brackets n minus 2 brackets 3n minus 1. Now starting with the left hand side, we'll write the sum of r equals 1 to n minus 2 of r brackets r plus 1 all squared. And now expanding the brackets out, we end up with the sum of r equals 1 to n minus 2 of r times, in brackets, so r plus 1 all squared gives us r squared plus 2r plus 1. And now expanding this out, we get the sum of r equals 1 to n minus 2. Now r times r squared is r cubed, r times 2r is 2r squared, and then r times 1 is r. Now we can split this series across the three terms to form three separate series, where the first series is from r equals 1 to n minus 2 of r cubed, and then we're going to add on the series from r equals 1 to n minus 2 of 2r squared, and then we're going to add on the series from r equals 1 to n minus 2 of r. And now we can write this as sum of r equals 1 to n minus 2 of r cubed. And now in this second series, because we have a constant of 2 being multiplied, we can factorize this out. So we have plus 2 times the sum of r equals 1 to n minus 2 of r squared plus the sum of r equals 1 to n minus 2 of r. Now if we use the formulae in the keynotes, we have that the first series becomes a quarter brackets, and now since our upper limit for this series is n minus 2 and the upper limit of this series is n, we're going to replace the n's in this formula with n minus 2. So we end up with n minus 2 all squared instead of n squared here, and then we end up with minus 2 plus 1 all squared instead of n plus 1 all squared. Now for the second series, we have plus 2 times, and now we're going to use the formula for r squared. So we have a sixth, and now instead of n, we again have n minus 2 here, and then instead of n within n plus 1, we now have n minus 2 plus 1, and then instead of 2n plus 1, we have 2 times n minus 2 plus 1. And now for this final series, we have the formula for the sum of r, which is plus a half, and then instead of n, we're going to use n minus 2, and then instead of n plus 1, we're going to use n minus 2 plus 1. Now simplifying each term, we end up with a quarter n minus 2 all squared, and then this bracket becomes n minus 2 plus 1, which is n minus 1 all squared, and then we have 2 times the sixth, which is equal to a third, and then n minus 2 in brackets, and then n minus 2 plus 1 becomes n minus 1. 2 times n is 2n, 2 times minus 2 is minus 4, and minus 4 plus 1 is minus 3. So we end up with 2n minus 3. And then this last term becomes plus a half, brackets, n minus 2, brackets, n minus 1. Now since we know that we're trying to show this series equals to the expression on the right hand side, we can see that we have a factor of 1 over 12. And so we're now going to factorize 1 over 12 from each of these terms. We can also see that n minus 1 and n minus 2 in brackets has been factorized out. Each of these terms has n minus 1 and n minus 2 within them. And so we'll factorize n minus 1 and n minus 2 out as well from each of these terms. So now we're left with, inside squared brackets, a 12th times 3, which gives us a quarter. And then since we factorize n minus 1 out, we now have a single n minus 1 in brackets. And since we factorize n minus 2 out from this term, we have a single n minus 2. The second term, a 12th times 4 gives you a third. We have plus 4. We factorize the n minus 1 out, we factorize the n minus 2 out, and so we're left with, in brackets, 2n minus 3. And then for the final term, a 12th times 6 gives us a half, so we have plus 6, and then we factorize n minus 1 and n minus 2 out, so this is the last term within this squared bracket. And so we now get 1 over 12 brackets n minus 1 brackets n minus 2, and now in the squared bracket we're going to expand and simplify. So we have 3 times, now n times n is n squared, n times minus 2 is minus 2n, minus 1 times n is minus n, and then minus 1 times minus 2 is plus 2. And then we have plus 4 times 2n is 8n, 4 times minus 3 is minus 12, and then we have plus 6. And so we then end up with 1 over 12 brackets n minus 1 times n minus 2. And now in the square brackets, if we expand the 3 out with each of these terms, we end up with 3 times n squared, which is 3n squared. We then have minus 2n minus n, which is minus 3n, and minus 3n times 3 is minus 9n. And then we have 3 times 2, which is equal to 6. Then we get plus 8n, and then minus 12 plus 6 is equal to minus 6. And so simplifying this further, we get 1 over 12 brackets n minus 1 brackets n minus 2 times, and then we get 3n squared. Now minus 9n plus 8n is minus n, and 6 take away 6 is 0. And now in the squared bracket, we see that both terms have a highest common factor of n, and so if we factorize this out, we end up with 1 over 12n times n minus 1 times n minus 2, and then we're left with 3n minus 1. And this is the expression that we were told to show in this question.